Good day everybody and welcome back to our SUSE Linux Enterprise Server version 12 training workshop. This is where we learn Linux the easy way. My name is Jaco Foster and I'm a SUSE certified training engineer for SABNT Tech. Should you have any queries, you can send us an email to suse@sabttech.com. As always, my colleagues are on standby to answer any topic-related questions, and you can send us for longer questions using our email address. Let's quickly have a look at today's agenda. Today, we'll be covering storage administration and remote administration. Both of these topics are very detailed and will only be covering some of the basic functions that you need to either administrate storage or to administrate servers remotely. Let's have a look at network management. Network management is a very detailed subject, and in this course we will be only looking at the major components thereof and the most commonly used commands. So let's go into our slides. When it comes to the Linux network management, we first need to understand a few terms. The first term we're going to look at is a device. A device is defined as the network adapter found on a system. An interface is a software component creating an interface to a physical device. When we look at the link, that's a connection of a device to the network. And then the address is an IP address assigned to an interface. Then broadcast is an address to reach all hosts on the local network. Then route, that's a path a network packet takes from the source to the destination host. And then our NAT, that stands for our network address translation. And the NAT translates the IP addresses of computers in a local network to a single IP address, for example, a router. We commonly use NATs with our home routers, where our local network connects to the router and the router is a single connection to the internet. When it comes to our Linux networking, there's a few network configuration files that we do need to take note of. The first one we're going to look at is our interface configuration file for each network interface. We replace the question mark in our config path with the network interface number. Our config path for our interface configuration file is on /etc/sysconfig/network/ifcfg-eth and then our interface number. The next one we look at is our system's host name. The purpose of a system's host name is to give us an easier name resolution when it comes to going through our systems. Instead of using IP addresses, it's a lot easier to use host names to navigate through all our servers. Our host names file config file location is on etc/hostname. Our local name resolution is where we define our local IP addresses and name resolutions itself. So in this file /etc/hosts, we will have our IP addresses typed in there and then a host name, which will usually start with our fully qualified domain name. In our case, it will be server1.suse.com, and then just an alias, which is a shorter name, for example, server1. Next, we have our DNS server. That's our domain name system. This is utilized to also resolve IP addresses should the IP address or the query to a name resolution not come from our host file. Then we've got a DNS server, and that will also aid us in resolving our names into IP addresses. And we use this commonly with internet to be able to go to google.com. That needs to resolve into an IP address, and we use a DNS server to resolve that address for Google at this time. The config file resides at etc/resolve.conf. Now we have the order of the name resolution services, which we can define within Linux, and that file is defined within the /etc/nsswitch.conf. Now open up your server so we can quickly go through our training over here and our practicals. So I'm going to open up terminal, going to maximize, and just then zoom in again so we can see a little clearer. So the first one we'll be looking at is our network interface. So all we're going to do is we're going to do a cat, and we're going to do /etc/sysconfig/network. Then the if, sorry, let's try if and cfg, and I'm just going to do a double tap here to show you what's available there, and then a -e where we want to be, and it automatically shows me that I only have one configuration configured, which is my ETH0 at this stage. So let's hit enter and see what a config file looks like for our network interface. This is where we can define our IP addresses and how it's also connected via DHCP, or it's got a static IP. A few other options are in here as well. We can also define our IP addresses within YAST. So we can run a network configuration utility in YAST and then define our IP addresses and our subnet masks in there. Next up, let's have a look at our etc host's name. So I'm going to first clear a screen so it's easier to read, and we go and look at our next command. Do a cat of /etc/host_name, and there we go, and here we can see that our server main host name is defined as server1.suse.com. We're going to look into the host name a little bit later in more detail. So the next config file we're going to look at is our etc host file. Now this file is quite important in networking, and we will be making some changes to this file a little later on. So we do a cat /etc/hosts. So in this file, what's currently important is that we have our servers defined. So we have two servers. Our first server's IP address ends with 21, and the second one ends with 22. Now I already have my main server, my second server started up. So should I ping this address or this name or even the alias, I should get a response from my second server, server 2. So the format is that we first put an IP address in there, then we put our fully qualified domain name, and then a short name or an alias. Here's the syntax at the top. IP address, fully qualified host name or domain name, and then our short host name. Okay, then let's clear this and open up the resolve.conf. Let's go cat /etc/resolve.conf. I'll hit tab to autocomplete that. This is where we define our DNS servers. On these labs, we are not using any DNS servers, but you can modify them in here or even within YAST. The next one we'll be looking at is our NS switch. Let's clear again. Do a cat /etc/ns switch.conf. And this is the order of the name resolution services. So here we can define how the systems look at our name resolutions and in which order. It will start at the top and we'll continue running it all down. The host file, the networks, and so forth. Great, let's quickly clear our screen and we go over to the next slide. Here are a few basic networking commands. The first command we'll be looking at is our ping command. This is a very common command, and the purpose for this is to test the reachability of a host on an IP network, and we can also set an option of the amount of ping counts. In Linux, when we start a ping, then it automatically pings the destination continuously until we press Ctrl+C to cancel the operation. But we can define the amount of pings we want by using the -C option. And we'll do a ping space -C, and we only want 4 counts, and then we will ping the alias or the short name for server 2. The next one we look at is ifconfig. This is to view the configuration of the network interfaces. This will tell us all the details of our network interfaces. Then we can also look at our if status. This displays information about a configured network interface. The command that we can run, and we need to define our interface, will be the if status and then our interface number. We already know it is 0 because we could see it on the previous exercise. Then we can also bring a network face up or down. The first one, we can bring an interface down if it was up, and we can run the if down command and also our interface name. And this will basically unplug the network connection from our server, like unplugging a cable, and you will no longer have a connection. You can also bring the connection back up again by doing a if up, and the command for that will be the if up and then again our interface name. Then there's another option if we want to do fault finding, especially when it comes to latency. We can use the traceroute command. This displays the number of hops and latency to the destination. In our case, we'll be testing server 2, and logically we're on the same network, so I expect very few hops. But you usually utilize this on bigger networks where there's multiple network switches. For example, let's use our internet as an example. Our systems are not connected to the internet, so we won't be able to test them on the internet. But a common test will be traceroute space, for example, the DNS of Google, which is 8.8.8.8. Then we will do a traceroute and see how our connection's latency is from our home office or wherever we are at home, and then have a connection out to all the service providers over the world until we reach the DNS server for Google. Then we've got the IP command. The IP command we also use to view configurations on the network interfaces if we use the option A. There's a whole lot of other options available with IP, and IP is very powerful, the IP command, but we're only going to focus on a few basic commands. So the first one is IPA, and that gives us a similar output to which we have with ifconfig. I enjoy using IPA because it's easier to type and it's got a more neater layout to my liking. Then we can also bring an interface down with the IP command. and that command will be IP, and then we say IP link space set, then our interface number, and a command down. We can also bring the very same interface up again by using IP link set interface and our number up, and it will plug in the network cable again. Then we can also display our IP table routes. Now the purpose for a route is to determine where our network connection will break out of our current network to the next set of networks. And we can determine that by using the IP space route command. Then we have another command called hostname CTL. Now the hostname CTL will display our host names, but more than that, it's got a few extra details which we will look at shortly. Let's bring up our server. And for our first exercise, we will be running the ping command. Before we start, please ensure that your server 2 is connected. And also ensure that over here at the top that we've got a network adapter on our NAT. So I'm just going to right click again on a network here and click settings. When it comes to our VMware workstation, click settings. And ensure that our network adapter is set to NAT. So this shares the host's IP address, meaning the computer which you are running the VMware player on. It will share the same networking address there, but it creates an internal network for us to communicate between the servers. Great. So let's start with our first command. Let's do a ping space server2.suse.com. And there I get a response. So I'm going to cancel the input, and it's continuously running with the Control-C command. So Control-C will quit that operation. Let's clear the screen. Let's do a ping. And this time we want to set a count of 4. So a ping space -C space and the number 4. And then our server name. Again, this could be the fully qualified domain name, or it could be just the alias that we have set. So let's quickly enter that. Now it resolves again and it gives us a response, and it tells us that what is the destination IP address. Now let's see what can we read from a ping. So first off, a ping pings with 64 bytes of data to our destination, and then we use our fully qualified domain name. We get a response from the fully qualified domain name and an IP address, and then the sequence is the amount of pings that's been pinging. So we after 100, you'll see about 100, the number 100 there. And then we've got a time to live, and that's the amount of hops that it can go and it will die. If we do not have a time to live, then the whole internet will be filled with pings and we have unnecessary traffic on our pings. So this is an auto kill within a ping. Should it not reach anywhere, it will auto kill. And then we've got our time in seconds and how long it takes to get a response from our destination. And our destination responded quite quickly in 0.2 milliseconds here, or 0.2 seconds, which is 20 milliseconds, or let's say here 0.7 seconds on our last ping. Now let's have a look at the next command, which is the ifconfig command. So ifconfig. And we can see we're not allowed to run the ifconfig command because we need to be a privileged user. So all of these commands we can run with sudo. For this purpose, let's move over to the full root privileges. To do so, we do a sudo minus I or SU minus is your choice. And we'll switch to the root user. Let's clear our screen. Now let's have a look at the ifconfig again. ifconfig, and now it should display us the information of our network interface. So here we can see our current IP address, and what's also important is our subnet mask at this stage, and then our link is up at this moment because we're getting a response from it. At the bottom, we've got our loopback address, and our loopback address is a local address if you want to run internal connection packets only. In this state, we can also see what's our receiving and transmission packets, and if there were any drop packets. So it gives us a quick diagnostics as well. We can oversee over time how much data have we transferred through our network by looking at the bottom line, and it shows us the receiving bytes and then our transmission bytes, how much we've received and sent over the network. Let's see if we can bring this connection down. No, not yet. Let's first look at our status before we do so. Let's do a if status ETH0, and this will tell us that our link is up at the state is up, and we're going to bring this network connection down. The next one will be the if down and then the ETH0 command. And our device has now been disabled. Let's do a status again. Just go 2 up with your arrows, and it will say that device is unconfigured and our state currently is down, so meaning the network cable is plugged out, if you want to use that as a reference. Let's do an ifconfig again, ifconfig, and we can see there is only one network connection configured at this stage. So if you want to compare this, it's more like the complete card has been ripped out of the box, rather than comparing this to a network cable being unplugged, but it gives the same effect. So let's bring our network back up again. So we use the if up, and we do the ETH0 with that, and that should bring our network card back or plug our cable back in again. So now it responded, yes, it's up. And let's do the status first, the if status space ETH0, and now it's back up again. Fantastic, it says the state is up. And we can do the ifconfig, and it shows us that our network adapter has returned, which is the ETH0. Let's quickly do the traceroute command. This is not really a fair test with traceroute, because we use this to test longer hops or longer connections, but this will give a quick idea. So we're going to test the traceroute to server 2, and we can see that we only have a single hop on our server, and our server, when it does a traceroute, it does 3 pings for us to tell us how long it takes to respond before it comes back. Okay, then our next command will be our IP command. Let's first clear our screen, and then we do a IP. So we first do IP, it will give us some options, but we want to view our network configuration. So we'll do a IPA command, and the IPA gives us a very similar output that we have with our ifconfig. It doesn't, however, give us some network stats. So our network is located here at the second listing in this case, which is our ETH0, and our IP address is over here, and we've got our subnet mask defined as a 24-bit mask, which is 255.255.255.0. Okay, then we look at the IP link set. We go IP link set ETH0, and we're going to bring this connection down. Let's go down, and let's do IPA, and currently the connection is supposed to be down. There we go, state is down. And we can also run some of the other commands. Let's quickly see what that did. Let's look at our IF status command. It should be up here somewhere. IF status. And the device is currently not running, and it is in a down state. Our next command will be to bring our connection back up again. So let's do an IP link set ETH0 and up. And let's first do our IPA, and our connection should be back up again. It's listed as state is up. And we can do also the status, the IF status to see, and it is back up again. We're just going to type the IP root to see some of the tables. We will not be configuring everything on this, but do note that it is possible to configure our root or add even more roots to our network configuration. Then the last command we'll be running is our hostname CTL. I'm just going to clear our screen. Now let's type hostname CTL. Hostname CTL, and let's run it. So here it gives us our fully qualified domain name, and it also gives us our shorter name or our alias. Then a few other informations are available in here, and what's quite nice to see with this command is which version of our operating system we are running right now, and then just a shorter name for the technical name for our version. And we can see our kernel that's running here is a 1412 kernel, and our architecture is a 64-bit architecture running on Intel. Okay, good. Let's have a look at the next slide, and that is just looking at our firewall basics. In SLES, we run the SUSE Firewall 2 for SLES 12. So a firewall captures all packets, both incoming and outgoing, and compares them against a set of rules configured by the administrator. So with our SUSE Firewall 2, we have a few zones. So each zone contains its own set of IT table rules. Then each network interface is a member of only one zone. So if you are ETH0, it can only be part of one of the zones defined. Then each zone represents a level of trust. So a host can therefore offer different services based on trust or untrusted networks in a defined way by the use of firewall rules. For example, we might have a public zone or an external zone or an internal zone or a private zone. All of those are type of zones that we have all dealt with, whether we are on Linux or on Windows. But when it comes to Linux, we specifically look at our external, internal, and demilitarized zones. We're not going to spend too much time on our firewall, but we are going to open it up in Yoast just to quickly have a look on what it's like. But we're not going to configure our firewall for our course. So the command to open up our firewall from Yoast will be the Yoast space firewall command. Then we're going to look at our config files where we can make some configuration changes to our firewall should we not want to use Yoast. So our main configuration file is located at etc/sysconfig/SUSE firewall 2. Take note of the capitalization over here. You need to spell it correctly. Then we can also define some of our service ports, and that is within our etc/sysconfig/SUSE firewall2.d. Alright, let's have a look at our practicals on that. Open up your server. I'm going to clear our screen first, and we're going to do a YAST firewall. So this will open up the firewall directly. In my case, the firewall is disabled. For our purpose of our training exercise, I would like us to keep it disabled as well. But you can enable the firewall, and you can even start the firewall daemon over here at this stage. So should you only wish to have the firewall enabled for this session only, you can start the firewall immediately, but on reboot, it will still be disabled. Okay. So this is an easy way of starting and stopping our firewall right now. Then let's have a look at our interfaces. Here we can see which interfaces we have and if it's configured to a zone or not. Here we've got a list of our allowed services for each zone. So I'm just going to go to the allowed services section, which is Alt-O. And it will show us the free zones that's configurable. We've got our demilitarized zone, and we've got our external zone, and then the internal zone. Each of them with their own set of rules we can define. If we go one down, we've got a set of predefined rules which we can use. You see it over here. Alright, and so if we'd like to add a DHCP server, we could do so. We could even add our secure cell server, which we use for SSH connections, or we can even add VNCs in there. So it really depends. It will just predefine a rule for us with the correct default ports. And once you have selected it, you just need to choose A to add. I'm going to show you one. Press A to add, and it will then start listing them over here. You can also go into the advanced mode and then add custom ports in there. And you can decide on which ports you want to have open in your firewall and add them separately for each type of port. I'm going to hit cancel over here, Alt-C. And then I'm going to delete that quickly. Although we're not going to save changes, I'm just going to delete that. Alt-T to delete. Really delete the entry? Yes. Then there's quite a few other options. We don't need to go through them at this stage. This is what you will learn in further courses. So let's hit cancel. We're not going to make any changes to our firewall at this stage. Alt-C to cancel. Do you really want to abort? Yes, we want to lose our changes. Now let's have a look at the main configuration file for the SUSE firewall. So let's do a cat/etc/sysconfig and then our SUSE firewall, capital S. So ensure you start with capital S. You can hit the tab button and it will auto-complete it for us. And hit enter. So this is where we can set a few settings within our firewall. You can go through this on your own time should you not wish to use the YAST utility. Let's have a look at our next config file, and that is the cat/etc/sysconf and then the SUSE firewall.d. Where's my D? / and then we want to know what port definition files on it. There's a little starter pack. So I'm going to hit tab to see if anything is there. So we've got our services, and in services we already have a few ports configs in there. We're not going to open any of them. I just wanted to show you that it is available. Okay. So you can clear your command, and you can see which service is already predefined. You can add some more or redefine each of them from here. Good, and that brings us to the end of our network basics. Our next lesson is remote administration. Again, this is a very detailed lesson and we will only be touching the basics. With remote administration, we have a few administration tools. There are many others you can use, but these will be our most commonly used tools. So we've got VNC, and then we've got SSH, and we'll discuss SSH in a lot more detail, and then a PuTTY utility. Let's look at VNC. In the SUSE Linux Enterprise, it provides us a management using the virtual network computing, the VNC, and it's configurable within YAST. So we are able, it's natively available within SLES, but not necessarily installed and configured. So VNC enables management via a graphical desktop. So it doesn't give us command line, it gives us GUI functionalities, although you can still do the command lines by going to a terminal. Then VNC is platform independent and it's open source. So it works in just about any platform out there, whether it's Android, Linux, Windows. So you can connect from any platform into our Linux service. Then VNC consists of two components. It's got a server component and a client component. We are not going to go into much more detail on this, but take note that it is available within Linux as an administration tool. Then the SSH, that's our secure shell, and we'll be using the Open SSH within our secure shell, and we'll discuss this in more detail a little later. Then there's another tool which we can use, and that is called PuTTY. It's a free SSH client, and you can go and download PuTTY from www.putty.org. Once you get there, you'll get to this little screen over there, and you can just click and download PuTTY over there. Just ensure you download the correct version for your system. A quick look at what a PuTTY will look like. So once you open it up, it is very configurable on the left-hand side. This is only half a screen, but the most important option is you'll put your host name in here, should you know that your host name will resolve, or even better, you'll use the direct IP address to which server you want to connect to. And then you have got a few options how you want to connect, and we will utilize the SSH functionality on port 22. So a very handy utility to utilize. Now let's have a look at remote administration using the SSH, using the secure shell on OpenSSH. So what is SSH? To summarize SSH, it's a secure encrypted remote connection between Linux systems. That's the main purpose. There's many other descriptions out there and uses for it, but its security is important. It uses port 22, but it can be changed in a global configuration file. Now, before SSH, we used Telnet, and we could do very similar things with Telnet. But the problem was it was not a secure connection, and any data that crossed the networks was available for everybody to see. So what does that mean? That means if we used passwords, people could sniff our passwords on a network and see our passwords or any content on it because it was not secure, the data. So SSH, let's quickly have a quick look at how the SSH system works. Now, when we make a connection from our client to our server, there is 4 steps that a SSH connection goes through. The first one is our connection is initialized and it uses port 22. So while this is happening, this connection, there's a few questions which SSH daemon asks. And firstly, it wants to know what's the public host key, and we send it back to the client. So once we have that, the server comes, it's got a client, it sends the public host key back to the client. But then in return, it takes notes of the current key from the host, and it saves the client key in the known hosts file on our disk. And the location for that is our home directory .ssh. Now that home directory is for each connection you make and is authenticated by the specific user. It will have its own set of known hosts. For example, Tux will have its own set of known hosts versus the root user. So that keys will be placed in there once you make a connection and you approve the encrypted connection. Then at step number 3, which happens in the background, there's a key exchange. And the key exchange is known as the Diffie-Hellman-Merkle exchange. At step 4, it approves the connection, and then a symmetric connection, a bidirectional connection is made. So we've got a unlocked session, but the content now is being encrypted, and nobody can sniff the content because they don't have your decryption key available. Let's quickly have a look at our SSH checklist. Now, this is not a complete list to problem find or diagnose your SSH connection, but this is a basic list to give you a guide on how to set it up and where to look for if there is issues. So our first point will be our ping. We need to be able to ping our destination server. In our case, we will ping server 2, and we need to ensure that we get a reply from server 2, meaning the host name needs to be resolvable. Otherwise, we need to use the IP address. Then we also need to ensure that the SSH daemon is running on our destination server. So we need to firstly go to the destination server and see if the SSHD service is running by using systemctl space status space sshd.service to ensure that this daemon is operational on its server to accept incoming connections. Then we've got our host names, and this is optional again. Why? Because we can use IP addresses. But should we choose to use host names and we don't have a DNS server, then we need to ensure that our hosts file have the right information in it. So in our host file, we have seen that our server 2 can work and ping. We've done that before, and our host file is correctly configured because it does resolve. Then you need to look at the firewall. In your firewall, you need to ensure that you have port 22 open, whether you're in an internal zone, external zone, or any other zone. You need to ensure that your port 22 is open by using the pre-configuration settings, or you can set it up manually. An easy way to see if your server is listening, your destination server is listening on port 22, is to use the telnet command. So we can use telnet space and then the server name or the IP address, then a space again, and then the port number we want to connect to. So once it does establish a connection, you can cancel that connection by pressing the Control key plus the square bracket. Please see the square bracket must show to the left. That's a closing square bracket. Then you'll go back to the telnet command and you need Q to close the telnet command. Then the last thing we need to check is to see if our network is not isolated. We need to be on the same network to be able to connect our two servers in this case. So it should be either on the same virtual switch if you are using a virtual switch through our VMware player, or it must be on the same NAT. Now previously we have looked at that, but ensure it's on the same NAT. Or you can use this on a breached network where you can breach the VMware player with your local network itself, and you can access all the resources on your local network. Now we're going to look at the configuration file paths and what they do. The first configuration file path for SSH is the global configuration file, and that is at etc/ssh/ssh_config. That is where we can define our global configurations. For example, changing the port number we want to use for SSH. Then individual user settings will be located under the home directory of that specific user, .ssh/config. Now, the .ssh folder doesn't get created until you make your very first connection, and then it's created on the remote server we are connecting to. The same goes for our known client connection keys. So the moment you make a connection, you need to authorize that connection and the encryption that will run. And once that is done on our destination server for the client that you are connecting to, the user, you will find it creates a .ssh/known hosts file, and that key, your client key, gets listed inside that host. For now we know there's a secure and a trusted connection. You can really define your SSH security to the very top level and only allow certain hosts and not every user also. So it's really configurable from here on in. A few commands that we'll be testing to see how SSH works is our SSH command itself, so we can create a secure remote connection to our destination. In our case, we'll make a connection to our server 2. Now, the purpose for SSH is we want to be able to remote administrate server 2 from our server 1 terminal. So we'll be connecting from server 1's terminal into server 2 as if we are sitting in front of server 2. Very similar like TeamViewer people use out there, or remote desktop that we use. But we are doing this on a command line base. Then after that, we will use that very same terminal connection and connect back to server 1. Because we are now connected to server 2 as if we are sitting in front of it. We are now making our first connection from server 2 back to server 1. Another good function with the SSH is that we can also now do secure copy over networks. Because previously when we copied data, there's a risk of our data that it can be harvested or captured by intruders on our network. So we can use the same security that we have and make a copy of our data over a network facility. So it looks like this. We'll use the secure copy command, SCP. Then we have our source and our destination to make a secure copy. So we will do the SCP and we'll copy from our home directory. We'll copy secure file1.txt. Now this file doesn't exist yet, so we have to create it. And we'll copy it to the tux user at server 2, and the colon defines on where we're going to copy it to. So we go :/home/tux, and that will define on where we will copy it to. If we use the tilde, which defines home, please ensure that we don't put a slash in front of it, because the tilde already defines the /home/tux. Now we'll be using that on our next command. We'll be using SCP, we'll copy from the destination server back to our local server. So we will state, we want to copy from our tux user at server 2 from its home directory, and we'll have a secure file 2 over there, .txt, and we'll bring it back to our very own home directory, and we'll place that file in our own home directory. So let's go and play on our server. Alright, so let's quickly clear our screen first. There we go. And the first commands that we'll be running is our ping command to server 2. Let's do that. Let's do a ping to server 2. And we've got reaction from our server, Ctrl+C to quit. So now we know that our server can accept this command. We need to note that the daemon is running on our server on the other side. So I'm going to bring up server 2 this time. Get my server 2 quickly. There we go. Try server 2. going to log onto my server 2. It's not been configured in any way, but it's just to quickly see the daemon. I'm going to run. I'm going to open my terminal. Just quickly zoom in a little bit. And let's run this command. We go system ctl, and we go status for the SSHD service. If you have a look, it's a privilege command and we're running this on tux. So we need to put something in front of that. Let's go sudo. And also take note that sudo has not been configured for the system to automatically run this. That's why I still ask for the password. We know what's the password for the server, and that's called Linux. We type in Linux, enter, and it looks like the service is running, and yes, it's active and running. Should your service not be running, all you have to do is run the same command and just put a start. And once you hit enter, it will ask you for a password, and you can just type the password and start the service. We'll be needing that shortly, so please do that for us. So let's move away my server. I know it's started and operational. The next one we need to look at is our current hosts file. So I'm just going to clear my screen. And our current host file. Let's do a cat/etc/hosts. And there we can see our current host file. And the reason why I get a response is because my other server network port is connected with server or configured with IP number 22. And because it's active and it's on our same network, the server2 command does respond. We can also ping it with the fully qualified domain name and it will still respond. Then we need to check if our firewall is open. So we will need to go to the destination server to check that. But the easier way to see if that port is being listened on is doing a telnet. So let's do a telnet to server 2 and the port number we want to test. In this case, we know it's port 22 for SSH, and we press enter. The moment when it states it's connected, we know it's listening to that port and it's waiting for our next command. So to stop this connection, we press the control and then the square closing bracket, and it will stop that connection for us. And then after this, we go and we can now exit telnet by pressing the Q button to quit. And it will close the telnet connection for us. Okay, and then we need to look at our network to ensure that it's not isolated and it's on the same virtual switch. For that, we need to look at our VMware player first. We've got our network connections here at the top, so we right click on that and click settings. And here we need to ensure that we are set on NAT, because both servers will run within the NAT functionality of the VMware player. You can use a virtual switch should you like to do that. Just ensure that both servers are then configured to run there on this one. And lastly, you can also do a bridge connection, and you can bridge this out to your physical network to make use of the resources on your current network, for example, printers or internet, or whatever you would like to use. But we are going to use the NAT functionality. Press OK. So now we have tested everything, we are certain we should be able to make a successful connection on our first attempt. So let's start with first looking at the configuration files, and then after that we'll go into our commands. Let's do a clear of our screen. And now we're going to look at configuration files. Let's do a cat of /etc/ssh_config. And this is the global configuration file should the SSH function be installed on your server. In SLES, it's defaultly installed. And here you can make a lot of changes on how you should work with the SSH service. You can also define on which type of security you want to enable, if you want to use the PAM authentication or anything else. This is really very detailedly configurable and takes quite some time to understand what you can do with this and set up the different authentications, public keys, relationships, and so on. Okay, so our next one will be our, first going to clear our screen, sorry, and there we go, and we do a cat of the current user. I think what we should do is we want to make connections to Tux, so we should exit our root server first. So let's quickly just exit now because all of these are now locally after this. So hit exit and let's go back to Tux. Because everywhere we're going to run now is going to be all with Tux, and we'll be running in the home directory of Tux as well. So first ensure that we are in our home directory, and we should be. Just check for your tilde over there or print working directly to confirm. Then we go cat and we go slash or home directory, then slash dot ssh slash config. So does this file exist? And it doesn't exist yet, okay, because there's no individual settings added. Now let's run the next command. So we're going to press the up key here, and we're going to change that to known hosts. Known underscore hosts. And it also states that it doesn't exist yet because there's no connection being made to the server 1 yet. So our next set of commands is to run the physical SSH commands. So let's quickly do that. Let's try to connect to our server 2. And before we do that, let's ensure and see what will change here should we make a successful connection. We're currently at Tux at server 1. Alright, so we'll attempt to connect to server 2. So I'll get Tux at server 2. And now this is the first time that we make a connection to server 2. And it asks us that we need to ensure that there's a trusted connection between the two. Now this is the easy way of setting it up. So we'll say yes. We type in the word yes. And it will now create on the destination server these or this folder specifically. Not any individual settings because we haven't configured anything, but it will definitely create us the known host. So let's go and enter yes. So warning, permanently added to server 2 to the list of known hosts, and we'll go to Linux, and now we have connected to server 2, and it's Tux at server 2 that we are right now. So let's do quickly a host name CTL just for the fun thereof. And it shows us that we are currently on server 2. And let's also have a look at our ifconfig. And we need sudo access, sorry for that. ifconfig. And because it wasn't defined, if you remember correctly, sudo wasn't defined to automatically be used for Tux. We must type in a password, which is Linux, and here we can also see that our IP address on server 2 is most definitely this IP address. Okay, let's clear our screen first. We are still on server 2, and on this server we want to SSH to server 1. But I expect there should be a problem because server 2 wasn't configured yet. So before we start, we need to just test if we can ping server 1. Ping server 1. And we have a problem. Server 1 does not respond. So why will that be? The next one, we need to look if the daemon is running on server 1. We can do that. Let's quickly minimize this. Let's open up a new terminal. And we run a command, systemctl status sshd service, and we should run that as sudo as well. Let's put sudo in front, sudo space systemctl status sshd service, and we know that on server 1 that it is running. We also know on server 1 that our host file is configured correctly for server 1, and we also know that there's no firewall enabled because we have checked that earlier. There's no firewall enabled on our server. So I'm just going to close this down for a moment. Bring back my server 2 connection, which we've made from server 1. And let's do the following on server 2. And let's see if the host file is correctly configured on server 2. So we go cat /etc/hosts. Okay, and again we need to have super user privileges. We go sudo cat, and it shows us we have a single entry only. So our entry for server 2 server 1 does not exist. So how do we add this? Now we already know how to work with command line in Vim, and we can vi etc hosts. Let's try something differently this time. Let's go and open Yoast. So we go sudo, and we do Yoast on server 2 this time. And we will need to look for our host names. There we go. On the network services, we go down and we'll find our host names. This is editing the normal hosts file. So we can add our host entries in here by using the host configuration file. So let's do Alt-D to add, and we can need to take note of what this IP address is. It will be 172.17.2 and then 21. So the IP address will be 172.17.2.21. That is the IP address for server 1. Then our full host name will be server1.suse.com, and then our alias will be the short name, just will be server1. Once you've added all that information, I'm just going to give you a moment. Double check your IP address, very important at this stage. 172.17.2.21. Ensure that your host name is spelled correctly, and then the server 1. Once done, press Alt-O for OK. And now we've added this extra entry. Once it's in, you press O for OK, and Alt-Q to quit the Yoast control center. So let's run our previous command for our host file again. And you will see it's now added our server in here. This is not very neat as our previous one, but it doesn't really matter as long as the entry is in there, and once it queries the file and it gets to the server 1 entry, it should respond. So let's do a ping again to server 1 and see if we can now respond. Fantastic, so we can do so. And Control-C to stop the response. So now we know that our server 2 does respond. We know the firewall is off, and let's just quickly do a telnet server 1 on port 22. Let's see if that works. That's an easy way to check if the firewall is off and it's listening, and it shows me we are connected, which is fantastic. So now we will quickly cancel. The escape character is that key over there. Oh, sorry, I had to press Control on this key. That is the square bracket, the closing square bracket. And then we need to press Q to quit telnet, and we're back at server 2. Now let's see if we can make a connection from server 2 to our server 1 this time. So we'll do that. We'll go SSH, and we want to do this tux at server 1, and we are making a connection, and because it's the first time we're making a connection to the server, it will also ask us to create a known hosts file. And we say yes, we're authenticated. We need to put a password for tux and hit enter. And now we are back at server 1. So now we can work on server 1 again. So what's important to take note is that we have moved into 2 terminal sessions already. So we're now at server 1. So if we type in exit and we want to exit this SSH connection, it will take us back to server 2, because we connected from server 2 into server 1 through SSH. If we want to close the connection of server 2 and go back to our main server, we can just press the exit button again. But we're not going to do that quickly. I just want to quickly show you what's listed in the .ssh. So let's do a cat, and we'll do a .ssh. And what's in there is our known hosts file. I've just hit tab because that's the only file that currently exists in the .ssh. And there we can see the configuration file, which defines that server 1 is now authorized and it's got a secure connection made to this. Should you make mistakes, you can always go and delete the known hosts file, and it will automatically recreate this file on your first new connection. So I'm going to now type in exit to go back to our server 1 connection. So now it goes 1 level back. And because we made a connection from server 2 to server 1, I expect to have that file in here as well. So let's do a cat for the .ssh and tab again our known hosts. Hit enter. And there we can see that server 2 is also defined as a secure connection because we made a connection from server 2 to server 1, and in server 1 defined the details in its own known hosts file. And that's an easy way of doing the remote administration through SSH. Let's also try to copy some files. I'm going to clear my screen. Now we're going to try to copy some files using SCP. But there's a file that we need to create, and that's called secure file 1. So let's do that. And we'll create it. So we touch a new file, and that's called secure. Let's check your spelling, please, that I'll also make a mistake. .txt. Secure file 1. That's on server 1. We'll create this little file over there. And our instruction says we need to copy this file, which is currently an empty file, to our server 2. So let's do that. I go SCP. We'll use the home directory / and you can type in the word secure file. Or the moment you tab it out, it will automatically resolve the tilde for you. And you can do secure file, there it is, number 1.txt, and we'll do that to the tux at server 2, and we'll do that to the home, and then / tux directory, and we'll close it with a /. So let's see what happens. It will ask us to authenticate. I'll put a password in Linux. Hit enter, and it states that it was copied successfully. If it wasn't, it would give us an error, but it completed with 100%. Now we need to go to server 2 and quickly go and change that file to copy the file called secure file 2 to us. How do we remote administrate? Easiest is SSH to tux at server 2. Hit enter. The password is Linux. And let's see if that file arrived in our home directory first. We go LL to list everything in our home directory, and there is a secure file 1, sorry. So let's add some data to secure file 1, and we'll do an echo, which is easier, echo, and we'll say the word server 2, and we will append the file for secure. You have to type it out, secure file 1.txt. So we've added some data in there. Let's quickly cat that file, secure file, and we've got the word server in there. Now let's also rename this file so we can copy it back for us. How do we do a rename again? We do MV. Then we go secure, from which file, and we go S again, and we'll just change that last one to a number 2. So this will rename the file, the MV command, if you can remember from one of our other lessons. The move command. Just going to stop here for a moment for you to catch up. So the purpose for this is to create our secure file 2, because we want to copy this file with the content of server 2 back to server 1 and see if we are able to utilize it. So let's hit enter, and now it have renamed our file. Let's do the LL, and now we know this file is called secure file 2. So let's exit server 2 and go back to server 1. So the next one will be to first clear our screen. So our last command will be to quickly copy that over to our server 1, that file. And it will be SCP, then tux at server 2, colon, and then we are going to use the tilde for us. And we go slash, and you have to type this out, unfortunately. Secure file 2.txt, and we want to bring that to our own home directory like that. Let's say enter, press the password, which is Linux, and it shows us that it has copied that file to our local directory called secure file 2. Let's quickly list everything within our home directory right at this stage. We go LL, and we will see that there is a new file called secure file 2. Let's see what's the contents of that file, and that we go secure file 2, and enter that, and there it is. It copied the server 2 file for us locally, and we are able to view the contents through that file. And this file was being copied using a secure channel. Now this brings us to the end of remote administration. This also brings us to the end of our lessons for today. I trust you enjoyed the remote administration with us, as well as the basic network commands that we've been running. We now have a few moments for some questions, and any longer technical questions, you can send us an email to suze@sabttech.com. For tomorrow, please ensure you have your ISO ready, and we'll be using that ISO to work through some of our commands. I am Jaco Foster from SAP Tech, and I will see you tomorrow again, same time, same place. Have a wonderful day. Goodbye.